Welcome back, everyone. My name's Leandra. I work at Forum Ventures. This is part 2 of the AI First Founder series. Last time we laid the foundation, and today we're going to go a little bit deeper. We're going to go deep on one of the most talked about and probably one of the most misunderstood tools available to early stage founders, which is AI agents. Our goal for this session is really to cut through the hype and leave you with practical hands-on tools for using agents to drive real value starting from day one. So here's what we have in store. First, we're going to start with Teija Bean, who's our head of product design at Forum Ventures in our AI studio. And she's going to share how her team uses agents from the earliest stages of validation and prototyping with real examples pulled straight from our studio portfolio. We'll talk about when AI agents actually make sense and, just as importantly, when they don't. And then Make is going to run a live demo building an agentic system for account enrichment. And we'll close out with Q&A, Forum and Make together. So without further ado, I'm going to let Teija take the stage.
Awesome. Great to meet you, everyone. I am going to be walking through a bit of an overview on how we're using agentic product to build at our venture studio and internally. But I also want to talk about some important things that, when are the right times to think about product agents or even just how you're using AI in your product in general. And that'll segue really nicely into what Martin's going to be talking about, which is a lot more actually building agentic workflows. So you'll get a deep dive after we chat as well. All right. Okay, so how should product teams be working in an agentic world? I know a lot of people are probably hearing the word agents flown around and they're probably experimenting with it themselves. So I want to dive into a little bit more about what that actually means in the context of your product. And we already know that AI makes execution faster, but human product judgment is still something that's so important and wins every time. I promise you, I'm testing so many different AI products, things to help you with workflows, prototyping faster. And one thing I'm noticing is that the human judgment and how we think about what we're building, our solutions and our products, our human thought is what's driving this AI to do its best work. So I don't want to omit that in this process. And I'm going to talk about how these things complement each other. So we're building faster than ever, and we're also failing for the same reasons. I'm seeing founders come into the studio now with, proof of concepts, MVPs. They have a product and they've been able to get to product or market a lot faster, which is fantastic. And it's accelerating that execution. But one thing I'm noticing that is not solving is understanding our customers, finding product market fit, prioritizing the right problems, and building the right workflow. And all of these things might seem obvious and might seem very AI 101, but you would be very surprised how some founders who are even repeat founders with previous exits are using AI, really to learn quickly and get to a certain place. But sometimes we need to take a step back and really evaluate and continue to empathize with our user and put that product thinking motion into play. So the bottleneck has moved, but it didn't totally disappear. So AI in product isn't just one thing. And before we're going to talk about agents, I want to really understand and separate the 3 different ways that AI is showing up in product. So number 1 is AI assisted. This is where you're doing the thinking and AI is making it faster. So some examples could be understanding your early product definition, product strategy, your research synthesis, wireframing. These are all ways that AI is assisting us in those processes. There's the agentic workflows where AI is doing the work. You're obviously setting a goal, you're verifying that work, but a lot of great examples are Claude Code, Cursor, Figma Make, QA agents. These are things with defined processes and easily measurable outcomes, and AI is really great at making discernment and judgments based on that. And then there's product agents. So these are actually things that we're building into our products to help people. So this is where your customers are interacting with the AI. And another example of that could be support agents, procurement agents, going and fetching different pieces of information and serving it to you, even moving in and out of other integrations, for example, document processing and agentic onboarding, all of these things that are helping move through processes and take action with and on behalf of the user. We're building these into our products as well. And that's an example of how we can actually create and use agents in the product, not just how we build. So really, there's so many different tools, but we really just have the same questions. Who should own the work? And so when it comes to who's owning the work, is it fully agentic? Is it, human in the loop, or is it, started and created by humans? I've developed a bit of an AI product framework to help how we think about this. So I want us to ask ourselves, where does the understanding or context come from before we're making these agentic decisions, and where AI falls into the process? So I've kind of put together a scale here of, where AI is leading all the way to human-led, and sort of what the definition of that would be at each phase. So for automation, which is where AI is executing repeatable work, you could do that with, filling documentation, doing QA, code generation, and structured workflows. So executing repeatable work is really easy for AI because we can say, if then, this is the outcome. It's predictable, and you can also instruct it very easily. So I think binary things are really good for AI, or like very strict reasoning to make decisions is when agents do really, really well. Where you kind of want human plus AI is the category I'm calling accelerate. So AI is strengthening your human thinking here. So it's more of your buddy to work through things, and you can do product definition work really well with AI. Your strategy, your prototyping, and your hypothesis testing. All of this is your thinking, and you're bouncing that ideas off AI in some capacity. It's assisting you in some capacity, but you're driving the outcome. So it's more of like a partnership as opposed to kind of moving autonomously as directed by you. And then another one is like, what's the anchor? So humans create the understanding at this level. And I think this is something that we really want to make sure that we're keeping top of mind and not forgetting. Because if you're not doing this anchor process really well, everything that happens at Accelerate and Automate is going to be garbage. And I don't know how many of you are starting to experience the AI slop situation where you're really not getting very good quality outputs. And it's because you're not creating and doing the work up front to actually give context to enable you to move through these other stages really, really well. And a lot of us are just trying to do things fast. And sometimes we feel like we don't have time to do anchor. And so customer discovery and talking to your users is not something you can get around. If you're going to be selling a product and you don't understand the needs and pains of who you're selling it to, or what's working and what's not working in your product, or how to do customer success really well with really high touch points and learn from that and implement it into your product, AI is not going to be able to do that human relationship management for you. The current and future state process mapping. So I don't know how many product people specifically are in the room, or if you're just an early stage founder, but if you are going to be understanding a current process and how to make it better, I guarantee you're going to come into learning how to do current or future state process mapping. I have done so much work to try and see if AI can do this for me really well. And the answer is I can't get a quality output that supplements me actually walking through a process with my user and mapping it out with them and asking questions. So many edge cases come out of that. So many integration understandings come with that, networks, the ecosystem. There's all this really hyper contextual pieces of data that come from these human conversations that I have not been able to replicate in a really meaningful way with AI yet. And I put prioritization here because yes, again, it can also be an accelerate category where you have a framework that's helping you prioritize, but ultimately you hold the all-encompassing context of your product and your company, and you're going to be the one that needs to understand what are the strategic roadmaps that you need to hit and how do you actually aid in that prioritization. So I feel like it's always good to gut check that with yourself, and then we can use AI to accelerate it in other ways. So here's an example of 3 different studio companies that we have built and we're building with this year. And I want to just give examples of these 3 different frameworks. So where Automate came into play, Accelerate, and Anchor. And it's really just kind of identifying like what work AI is owning and where the human loop is coming in. But our first example is a company called EasyOps. So EasyOps does purchase order operations management for retail brands. So what that means is when any brand is going to enter into selling into big box retailers like Walmart, Target, any of those companies, there's a ton of compliance rules that they have to meet in order to even be accepted into the retailer. And if they don't meet those, they receive tons of chargebacks. And so there is a flow that essentially any brand has to go through to get their product onto the shelf. And we're basically helping automate and resolve a lot of things in that workflow so you can do it in a compliant way and maximize your margin and kind of reduce chargebacks. But one thing that we wanted to focus on is really automating and defining this workflow with AI. And so in the product, we're auto-processing really routine PO workflows. We have a guidebook that is essentially, here's the rule set for that retailer that we need to abide by. It's continuously being updated. And how do we move a PO or a purchase order through this life cycle in a way that is compliant and correct, and then flagging edge cases for human intervention? This sounds really, in a way, we're like, oh, why couldn't ChatGPT do that? Really, the nuances and complexity web is so great that we had to figure out how do we build an algorithm and use AI to help us, auto resolve and move things through this workflow and then reveal what's still left for humans to resolve. In the build process, we needed to validate our accuracy first of a lot of our calculations and numbers and gut checks against our compliance rulebook. So really, we are automating formatting and presenting that information. But realistically, we can only automate so much. And then we have to be able to build checks on calculations and numbers. Half of that is done with AI. And then obviously you have like a final human review on that too. So for the automate, that's one example. Another one is with a company called Fexel. So Fexel is AI workspace automation for industrial products that are using warehouse layouts. So as an example, if you are a company that has a factory of some sort, there's different automation layouts for conveyor belts and packaging and processing that you would go to a company to be able to tell you how to lay out your factory. And so these consultants and other manufacturing companies need to be able to develop these proposals for their clients in a way that is not taking up too much of their time, because they're very senior engineers that are very skilled in automation of warehouses, and they're developing these detailed 3D renderings, and it's taking a lot of time. So we actually want to figure out how do we accelerate the work of experts in this case. We want experts to be able to spend less time doing proposals, and we want them to have more time doing the actual work so they can actually close contracts. But how do we get that level of fidelity that we need in a proposal for a client to say yes? So as we did is we're actually accelerating that process through this product. So in the product, we want to make sure it's generating accurate proposals and project briefs and first drafts. And then the engineers and consultants are refining the final solution. So really, we're accelerating getting to a first view, and we still need their expertise and their eye to kind of tweak some things, put edge cases and parameters in, but it's getting them there in maybe a couple hours as opposed to a couple weeks. And so within the build, we needed to also be able to prototype and iterate something that our design partners could react to. So obviously rapid prototyping came into play here. We could run a lot of closed tests with development and our engineering teams in the back end by using our different 3D components. How are we visualizing 3D components inside of layouts? So being able to use rapid prototyping and all of the different tools with coding and AI to get us to this place really helped us iterate faster with our design partners and understand what a good quality output looked like. So it accelerated for us, and we built that acceleration into the product. And then for provision, So this is a revenue cycle platform for community health organizations. So essentially, we're trying to simplify Medicaid eligibility for billing food as medicine. So this is something new that's happening in the US, where you can actually have billing codes with your insurance to bill food as medicine for specific health issues. And so we actually want to build like an insurance and billing resolution platform around that, so we can have these codes resolved quickly. People can get the medicine that they need, and also the providers can have that billing simplified. So how did this anchor piece come into play? So we really wanted to anchor our understanding before we decided what we were going to automate. There's obviously, in any straight through process, there's tons of opportunities to automate. But here, because of the hyper complexity of insurance billing, there was no way AI was going to help us with that current and future state process map. We had a design partner that deeply understood Medicaid. We sat with them for multiple hours, to be honest, to really understand how do we understand this web of the current state so we can actually handpick the automation pieces. And ultimately, humans are managing the denials and these complex exceptions. And so if we don't talk to people to understand that, AI can only surface so many assumptions, but they have to be validated in real life. And so we validated all this with experts, and then we were able to actually flag and put together what was our V1 automation plan going to look like. So every product that I've shown here actually uses all three. I just showed a highlighted example of the automate and the different parts of this workflow, but really the decision wasn't whether or not to use AI. It was more whether AI should lead and where humans are and when. But really, everything's using AI today. That's not something new that you've heard. So it's not if, it's how and when. So I also just want to highlight, here are some of the mistakes that I'm continuing to see founders make, and then hopefully you can avoid some of these pitfalls. But one thing that's continuously coming up is people are building before understanding, as I mentioned. So AI is making it easy to prototype, but you haven't even validated the problem yet. So continue to go out and validate your problem as a real business need and pain, and then you can use all these tools to accelerate. But they're also automating specific judgment calls that should be done with humans in the loop or started with humans. So some work is creating understanding, like I mentioned, and the process maps are a good example of that. That's why I keep coming back to that. But really, you don't want to outsource your learning just for the sake of speed. I feel like sometimes we forget to talk about how AI is doing a lot of things for us, but we're still really intelligent, and that context that we provide is really a part of that secret sauce. And I really don't want us to forget that as we continue to build products and bring them into the world. Because if we forget to empathize with people and forget to understand the problems we're solving, AI can only get us so far. And so we're kind of starting to see that sometimes when we get lazy and kind of what AI slop comes out. But also sometimes we're designing for automation a little bit too early. So we don't want to orchestrate 10 workflows before you've perfected one. Yes, automation is great, but let's really understand like the core job to be done and how we really fulfill that function very, very well before we figure out how can we do more with the speed that we have. And another example I want to highlight is really even the most agentic native teams are really protecting their product thinking. And I want to use an example here of GStack. So for those of you who don't know, GStack is an open source engineering workflow. It was created by Gary Tan, and he's the CEO of Y Combinator. And essentially, the goal of this was to try and figure out how do we create and generate and ship more lines of code faster. And so they did an experiment of trying to ship over 600,000 plus lines of code in 60 days. And at first glance, if you go onto GitHub and you look through GStack, it looks like maybe an argument for how do you replace your product team, but it's actually the complete opposite. And when you look at it, what it actually is 15 different specialized roles. You have combinations of agents and AI assisted flows for all of these different roles in a product team, product manager, engineering, staff engineer, QA, security, CEO, technical writer. These things are already built in, but each role has very specific, clear responsibilities. They have the defined inputs and outputs. They have very limited scope, and they have human checkpoints. So realistically, we're trying to build the things that humans had into these models. And then there's opportunities where we're surfacing gaps that we actually need to provide that input and those quality checks. And so an AI native product function, how that scales into the future and is starting to scale today, and Martin's going to be showing you a little bit about how to actually work in some of those agentic flows, is really product leadership. We're really still focusing on vision, strategy, customer priorities. How do we define the problem that we need to solve? AI can assist, but humans really need to be driving that, because if anybody remembers design thinking principles, empathizing with your user, or empathy is the first stage. And I really think humans need to stay involved in that. But the product thinking layer, obviously design, engineering, really great to leverage tools to help us do those things faster. And once we feel like we have a good understanding and we're able to collect the data and make those discerning choices, we can build that checklist into the AI and prototype against that. And then we can also develop all these different agents that help us. What is our internal research function, our design function, coding, QA? All of these things can have agents. And so our product teams are just going to be really excellent orchestrators of agentic tools. And so it's not really like our product team is going to be getting smaller, but we need to become AI specialists in our field. So to wrap all of that up, I have created Before You Build Claude skill. And so if any of you are familiar with GStack, and one of those components is called office hours, really this is just a prompt flow to help you think through various pieces of this product understanding and product lifecycle. And so it's going to prompt and ask you questions. You can drop in documents, you can drop in any context that you have, and it'll help stack rank and evaluate what you have, what you need to do next. Should you put AI in the loop, automate this piece? How do you get to a next step? And is it a pass fail, right? So really helping you put that product thinking first. You can even, talk to your AI and have like stream of thought into this tool. And then hopefully it's just helping you move through, and then you can make the decisions that you need to make with AI. And that's about it. So thank you so much, guys. And I will pass it over to Martin, and he's going to give you a bit more of a deep dive.
Oh, Teija, since you're here now, once again, thank you so much for all the amazing insights. I have several things that I would like to just quickly follow up on, and then I'll build a narrative for my section as well. First of all, just the latest thing, the Claude skill that Teija shared. I would encourage all of you to go with it. And even if you're coming from Make specifically, and you're building with Claude to create automations within Make, feel free to use it as well before you even ask Claude to build automations for you on the Make platform, because this is the same type of use case as well. Whether you're building in Claude, whether you're building directly within Make, the thinking and reasoning still remains completely the same. So for this one, and this kind of ties back to one point that I wanted to follow up on, and that is building for autonomy too early. And the reason why this resonated with me a lot was that just yesterday I read a book that's called Becoming AI Native. It's by Nate Herg, who's probably one of the most prominent content creators in AI, and he actually shared what he calls a J curve. So a J curve is that at the beginning of all of the autonomous system that you're going to be building, you're actually going to be losing your time, because you're firstly going to be investing into it, and until the moment that it becomes autonomous, it actually takes a lot. And I can see this in myself as well, because pretty much all the agentic systems that I'm still using to this day are at least several weeks old. They haven't been built in like a few days. It actually took a lot of iterations, and I'm going to go into that as well a bit more. So I'm going to be talking about agents today. Once again, thank you so much for joining us today. In this section, we're going to be going a bit deeper into agents specifically, and we're going to be talking about the Agentic playbook. Before that, let me quickly introduce myself. My name is Martin. I work at Make and I manage our startup program. This means that I work a lot with founders, but also VCs and different startup organizations to help early stage companies simply understand AI and automation better. I also function as a mentor in Station F in Paris, which is the largest startup hub in the world. So I get touch points physically with the founders as well and see what they're struggling with, how they're thinking about AI in such a prominent place. And today I would love to share some of that knowledge with you today. So many of you, I assume, came already from Make, but just in case you're not fully familiar with the platform, I'm just going to quickly introduce it. So in a very practical way, I would describe it as an AI automation platform that you can use, of course, without any coding, but it functions as an integration tool. This means that it connects to different platforms, to different softwares, to different tools, and it brings them all in one visual place where then you can orchestrate and build AI agents, but also regular automations and AI workflows. So what surprises a lot of people is actually that Make is over 12 years old right now. This means that we didn't start as an AI native company. We started as an automation company. And it's been at the beginning of last year when we started seeing headlines like these. So a lot of different messages, a lot of different news about AI agents. And we already knew that this is something that we truly need to double down on. And today I'm going to be talking about, firstly, we're going to run through what the AI agents actually are. I'm going to then talk about some practical takeaways, what to keep in mind when you're going to be building AI agents. And then we might also go into something a bit more practical like a build as well, if we're going to have time for that, of course. So let me run you quickly through what are AI agents. I know that pretty much everyone already heard of AI agents. You know what AI agents are. But just to quickly clarify, agents are systems that independently accomplish tasks on your behalf. But what they actually are is something that we need to look a little bit deeper to understand so we can build them in the best way possible. So AI agents are powered by three specific things. And those are the AI, the brain, or in this case, the LLM, then the context, so the access and the knowledge you provide to the AI agent. And last but not least, the tools. So these are what we like to call the hands or the actions that you allow the AI agents to use to get to the objective or to the job that you gave to the AI agent in the first place. So when do you use AI agents? If you look at it more broadly, what are some of the use cases and how are you supposed to think about AI agents specifically? So we like to say that you should use AI agents for workflows that previously resisted traditional automation. Now, what does this mean? This can be automations, operations, systems with complex decision making, with rules that are difficult to maintain, and some workflows that rely a lot on unstructured data. You can think of, for example, things where there is a lot of text input, a lot of unstructured text input, and when a lot of different variables need to be taken into consideration for you to make a judgment or a decision. So when do you then not use AI agents? Because let's be completely real, and this is something that Teija also spoke about as well. AI agents are not something that you should use for every single problem that you have, even in your business or even in the task that you're currently facing. There might be better solutions for the specific problem, because ultimately, how I like to think about AI agents is still as a problem-solving tool. So when do you not use AI agents? And I would recommend to not use AI agents for workflows where accuracy is absolutely crucial. So these could be your operations that are business critical, where it's essential to have a specific correct output, because there is just a lot of dependencies that are tied to that decision. So once again, three different examples. So these would be workflows that are purely deterministic. One thing that Teija mentioned was also binary decisions. I think this is a bit more nuanced, because if the inputs are binary, then using an AI agent doesn't really make sense, because if it's binary, then we can very deterministically think what the actual outcome of that would be. If the output is binary, but everything else, the input, is not binary, if it's unstructured and it's very complex, then it would make sense to use the AI agent. So you should not use AI agents for workflows that are strictly rule-based and when there's reliance on structured data, as I said with this example. So how we like to think about automation in Make is in terms of a spectrum. And the spectrum is the extent to which generative AI determines the very behavior of the specific process. So on the left-hand side, we have automated workflows. So these are fully deterministic. These are the ones where you have a predefined reasoning and predefined logic, like if this, then that. If you introduce LLMs or simply AI into that business process, you're also introducing some more non-determinism or a bit of fuzziness, because then the AI is in charge of the ultimate result of the process. Last but not least, what we're going to be talking a bit more in depth today about is the agentic automation or the AI agents, which are fully non-deterministic. This means that all the inputs that you're going to provide into it, it has the autonomy to do the tasks and get to the objectives fully autonomously. So as I'm working with still a lot of early stage companies, but also companies that might be a bit more mature, I still do believe that most companies are not quite ready for AI agents yet. And the reason why I'm thinking about this is because there's a lot of prerequisites that come to what we call production-ready agents. And Teija spoke about the understanding of the process, which is one of the very important things of that. But to actually have those agents function properly, you should have well-connected systems, clean and accessible data, and really well-integrated AI into your processes. So what makes an agent production ready? There are 5 components that I'm going to be sharing, and then we'll go a bit into a few tips how to actually ensure that this is going to be the case for you. So firstly, the orchestration part, which is the brain. So what you need to ensure is that the LLM or the brain has very clear instructions and that it can orchestrate the tools and the context in the way that is going to increase the chances of a successful outcome. This is very straightforward. So this is really tied to the prompts. This is tied to the tools that you give it, but also the environment, which is something that ties to the immune system or the resilience. The resilience is very strongly tied to security, to integrity of the data. So when you're going to be building AI agents, the agents themselves are not the only component in the grand scheme of things. It's also the place where you're building them, what sort of access you give to them as well, and ultimately like how well functioning of a system is around those agents. Which brings me to the next point, which is observability. So what we like to say in Make specifically is that we try to build the product like a glass box, not like a black box. Because since AI agents are autonomous, they do the decisions and reasonings on their own. You should have as much visibility as possible into like how they make the decisions, how they do the reasoning. So that's why observability, seeing how the agent is accessing the tools, how it's using them, what sort of data points it's taking to make those decisions, is something that's going to be very essential for production-ready agents. Security, this also ties strongly back into resilience, but for this one, we're going to be specifically talking about guardrails and also evaluation systems. So for guardrails, it's of course extremely important to capture edge cases and to know what the AI agent actually should not touch at all. So lastly, what we also think is very important is the interface. So this is the UX of the agents, and this is simply because you ideally, for AI agents to function well in a team, you want as many people as possible to understand what is going on behind the hood. So if the UX and if the interface is clear, it's going to be much easier for more people and especially for you to understand what the AI agent actually does. So making this production ready. So on the side of the reliability, Error handling that's fully built into the AI agent. So whenever you encounter any errors, it's always important to tackle them straight away and to build them in a way that it doesn't happen again. So retrying for API failures and building validation gates when they catch specific issues, for example. In terms of the observability, every decision is very clearly logged in a standardized way. Execution history is tracked, and debug failures are handled very quickly. So in Make, what we try to also build within the platform as well is that you have this vision into what happened previously and how it impacted how the agent behaves in the current moment. Scalability, this is also an important concept because the best agents are, in an ideal world, of course, going to be behaving better as the time goes on, as more data passes through, as they learn more about the task and the data that's going to be provided to them. So they also should be able to handle thousands of different requests daily, even on hourly or per minute basis. So one thing that is also something that many people don't really think about is how much time it actually takes you to manage the infrastructure around the agents, and whether that time is not actually a bit spent in a paradoxical way. Because if the whole thing that you do is manage the agent, then the time that you would save with that agent is coming back into it. So you're actually not getting as much value as you would be getting from an agent that would function in a really well-maintained environment. This ties me to the last point, which is probably ultimately the reason why we even talk about this technology in the first place, and that's economics. It simply needs to make sense for you to build agents. You need to look into how much credits it's consuming for you, how many tokens it's using, if it's optimized for making profit at the end of the day. So the real win is, of course, going to be when the agent makes impossible and scale viable. So this is an important thing that you should always keep in mind whenever you're going to be building. Does it actually make sense financially for me to build this in tool X or in tool Y, for example? So best practices for AI agents. We're going to be looking into all of these three components that I mentioned previously, and I'm going to give you some practical ways of how you can improve each of these components to get best possible outcomes. So how we like to think of this and how I would also structure the thinking around agents is that you should always focus on the problem and work your way backwards to the solution. Then starting small and iterating, as I spoke about the J-curve, for example, starting small and actually realizing that initially it's going to take a lot of time for you to build something that's going to be production ready. This type of mindset is absolutely super useful for you to have as well. And then also combining different approaches. So the AI agents do not need to function for themselves. The tools that they actually have can not only be databases, but they can also be other workflows or other AI automations as well. I'm going to be showing a few examples where this is very clearly depicted, and it's some of the use cases that I actually built out and I use to this day as well. So for the best practices, so when it comes to the LLM, as I already mentioned, system prompt is going to be your highest leverage, but also choosing the right model. So different models, of course, are built on different data, and for some, another one could be a better choice. So testing and trying is going to be the best bet for you. But when you're going to be using the prompt agent to break down the tasks very clearly. And the reason why I'm saying this is because prompting AI agents is very much different to how you would be prompting a regular LLM, because you should always very clearly describe what sort of actions you're expecting from the agents and what sort of tools it has access to and how it should be using them ultimately as well. Defining guardrails. This is a thing that you can, of course, mention specifically in the prompt, and it's something that you should be thinking about from the start as well. For the context and some of the best practices, use existing documents that you have within the company, guidelines, just so you exclude sensitive information as well. avoiding anything that could dilute the thinking of the AI agent, because ultimately, if you're going to be prompting the agent, you should also let it know what it should be looking into first and under what circumstances as well. So giving examples of inputs and outputs for the context is very important as well. This can be done through regular PDFs, or you can even connect the AI agent to, for example, even a vector database, if this is something that you would like to go for to make your agents simply more smart. That's how I would put it. Lastly, the tools, very importantly, provide a thorough description of each tool, because how pretty much every agent functions is that it always reads the description first, and then it decides to use the tool or the workflow that it has access to. Once again, defining inputs and outputs of the tools, super important as well, and including robust error handling. So whenever there would be something that could potentially stop the AI agent, is already thought through and handled. Last but not least, building evaluation systems early. And the reason why I believe that that is very important is the following. I'm going to spend a little bit of time on evaluations, because I feel like this is the type of topic that's not really covered as much in depth, but a very high level understanding should provide you with a lot of value when you're going to be spending time with building the agents themselves. So the AI agent evaluation is the practice of measuring how well an agentic system plans, reasons, utilizes tools, and achieves goals. There are several components to AI agents and several ways of how you can build agentic systems extremely simply to cover majority of the cases where they would actually be necessary. So for the levels of evaluation, you should know 3 different ones. This is the end-to-end evaluation. This is the one where you're scoring and looking into the input, the trajectory, the trace, and also the output of the agent. So you're looking at the different components and scoring them each to then pretty much give the feedback to the AI agent so it can perform better next time. You can also just simply look into the trajectory. This is pretty much the reasoning and how it reaches for specific tools, how it reaches for specific information, and then how it ends up using them as well. The component level is quite self-explanatory. So this is you giving the agent feedback on how it used specific components. So how it used this tool in comparison to the previous run, and how it used another tool with a different data set, for example. How you can very easily do this is with LLM as a judge. So what you would simply do is that you would include another large language model to judge the outputs or judge the trajectory of the agent that is going to be processing the inputs. What is always a great practice with this is to have a different model of the LLM to judge the first one. What I like to do, for example, is if I'm using agent through Claude, or if I'm using agent through that is built on ChatGPT, I then have a Gemini LLM that is evaluating that specific output. So to correct the AI agent, you can look, of course, into simply reprompting. This is going to be the easiest one for you to implement. What you can also do then is with the LLM as a judge, you could prompt it in a way that is going to be putting out the prompt that you can then insert directly into the agent as well. You should always be a bit careful with this, and there should always be a human in the loop to check whether that prompt makes sense for that specific agent. And ideally also have checkpoints for when the agent is going to be reaching for each and every option. So the critic model is something that you should define from the beginning. So what I also like to advise is that the LLM as a judge should likely be a better model than the one that you're using for the agent. What I wouldn't recommend is building agents that are pretty much always using frontier models, like, for example, Fable 5, just because since you do not really have as much autonomy with how you're going to be using the agents, if it decides to go a bit rogue, you're risking a very high cost for the agent. That's why rather having LLM as a judge, the frontier model is, in majority of the cases, a better choice. So TLDR, to wrap this up for the AI agent specifically, use AI agents when tasks need judgment or reasoning. You work with unstructured data, so text, documents, or maybe chats as well. Rules are hard to maintain or constantly changing, and workflows that should be adopting dynamically. Don't use AI agents when tasks follow clear, fixed rules. You work with structured data, or rules are simply stable and really predictable. This also, for example, ties to speed and reliability. Reliability is a big component that most of the times when you're building within the AI agents, it requires a lot of attention and capturing all the edge cases that I've spoken about. So if it needs thinking, use an AI agent. If it just needs doing, use automation. This is a very simplistic way of how to talk about this, but this is sort of the TLDR of when you're thinking about using AI agents. So our learnings about building with agents is agents rarely work well without deterministic foundation. What I mean by this is with the tools that you provide to the AI agent, likely there should be a bit of determinism there, because as I said, not every problem requires a autonomous decision-making solution. There are aspects where having binary outcomes is desirable, and this deterministic foundation that you will also see a bit in practice. So obsess over safety on an environment level, not use case level. So what I mean by that is that when you're going to be building multi-agent systems, they're still going to be living in the same environment. They're still going to be having access to the data that you have, let's say, on your desktop or in your cloud database. And this environmental level should be the one where the safety is most obsessed over. And last but not least, most issues with agents are not caused by LLMs. So when we talked about the tools and the context, this is rather going to be an important way of how you can make the agents much more reliable in the long term. So let me share with you a few examples of how we do it internally within Make. And then I'm actually not sure if we're going to have time for an actual build, because this would take at least a few minutes. So what I wanted to at least share is some of the use cases and some of the agents that we use internally and that have provided tangible value to not just one person, but actually teams of several people. So the first one that is being heavily talked about in our company is what we call the post-call hero. The reason for that is because this is pretty much a sales assistant. And with sales assistants, you can very clearly define what sort of value you're getting back. And this one was sort of a natural fit, because what this one is doing is that it is creating internal notes for our sales team. It's taking the transcripts from the calls that are being carried out by a team of 50 people. So our sales team is also growing quite rapidly, and having this standardized system to then keep everything tidy and to generate follow-ups, to propose Salesforce updates is something that is generally saving several hours per day for each and every salesperson that is doing this. And you can see that on the right side, these are all the different scenarios or different deterministic automations that are connected to the agent. So depending on what the agent is supposed to be doing, it's going to be reaching for these deterministic tools first. So in some cases, of course, when there is an update that needs to be done in the CRM, this necessarily doesn't need to be handled agentically. If there is a specific set of steps, which in majority of the CRMs is, this should rather be handled deterministically, which is handled by a regular workflow automation. Moving on to the next example. This is our startup program agent, and you can see that it's relatively complex, but let me explain what it is, how we use it, and how we focus on different components to this one. So as I mentioned, I manage our startup program at Make, and currently to this day, we have over 12,000 startups that have registered and use Make through our startup program. This means that when we're getting new registrations, what happens is I do not have capacity to go through all the information myself, and I built the system to help me out with that. So how this works is for the eligibility criteria that we have in the startup program, it checks whether the startup is not already a paying customer, whether they already applied. And through the information that the startup provides us with, we also have an agent that is double checking the legitimacy of the application and the person. So what it does is that it looks into the website, it scrapes the LinkedIn profiles, it looks into the person as well, whether it works in the company. And you can imagine that if I would be doing this manually for each and every person, this would take me at least several minutes for each application. And you can imagine how much time there would be for 12,000 different ones. So what I wanted to point out with this specific agent or with this specific system is that the agent is actually just a single part of the whole system. So this is the agentic part, and this is simply the part that is looking into the website, the LinkedIn profile, the person as well, because there's a lot of different inputs and there's a lot of different ways how you could approach it. There is a lot of unstructured data that goes in, but for decisions such as whether the person applied or not, this is a binary decision. So this can be handled deterministically, and it can be done even prior to when the agent starts doing any decisions. This is why when, for example, the startup already applied, the agent doesn't even needs to be triggered in the first place. Whereas if this would be only handled through the agent would be going through the whole thinking and the reasoning every single time, which could then spike up the token and credit usage. So what I wanted to point out with this one is that you should always, or let's say not always, but it's recommended to mix and match different approaches and thinking whether even that specific task needs the AI agent. And if it has enough unstructured data for the AI agent to provide value to you in the first place. So I would like to wrap up my section of this session, and I would like to open up the questions from the chat. So thank you so much.
Hi. Okay, we did have some questions in the chat. Teija, we had a question for you. The question was from Savita. The build your skill assumes B2B companies versus B2C because design partners are more likely in B2B. How would you change with B2C? They've done 100+ interviews. They're building from their own lived and living experience. What would you change for B2C?
Yeah, I think everything really does stay the same except for what counts as evidence or proof of the product actually resonating. So a lot of that on B2C is how many people are actually using it in this cohort and what are you actually measuring as your KPIs for success. So instead of design partners, you would still have KPIs for success, but this you want to use your sample size of users and understand the trends in what that feedback has actually been as a pass fail. And then I think also because you're mentioning that you have that lived experience of your user, I think you actually want to do your best to try and remove yourself from it as much as possible. You can give assumptions, you can have solution hypothesis, you can build towards that. And then to remove your bias, take a look at the data and say, okay, how many people are validating what my solution hypothesis was? So if you're having, a cohort of 100+ people, what percentage of that is actually moving and proving what you have validated? So I think it's more just how you're actually going about validation with cohorts of people versus a design partner. I think that process of that validation is very similar, but there's also others like tiny nuances in direct to consumer or B2C and B2B, but this is more just your product thinking as a base, which actually doesn't change too much. Obviously, go-to-market is different and other things. But for the actual skill that I shared, I think the main difference would just be, what counts as evidence towards proving a solution is different.
We had a question from Claire, and maybe this is something that both of you can answer. How do you decide when an LLM as judge is trustworthy enough to auto approve an agent's output versus routing to a human?
That's a really good question. And in this case, I believe you should approach it in the same way as you would approach agentic evaluations. So if you really want to make this reliable and have sort of another line of defense, is that you should also evaluate the LLM as a judge. So likely you will already build an agent that has an evaluation system, and that evaluation system runs through the LLM as a judge. But for the first several iterations or for the first several runs, you should absolutely log all the outputs of the LLM as a judge and then also score them. And when that score reaches or exceeds a specific threshold, so let's say this would be like, if it's a very reliable process, it should be like 9.9 out of 10. So 99 out of 100 tries it's the accurate assessment. Then you can put it into production. Of course, it doesn't need to be 100. Depends on what you can take. But you should also, in my opinion, take it as an evaluation as well. So even if it's LLM as a judge, and you can do it with several different LLMs as well. So this is going to take a while, but if it's worth it for the process, absolutely go for it.
For many human experiences, the LLMs there's still no available data used in their training. It also doesn't account for a diversity of human experiences because most data used in training is American mainstream centric. So I agree with LLM as a judge percolating the biases.
Well, okay. Interesting comment, I think, because I mean, there is a lot of different LLMs that you can use as well. And really depends on also like what is the value that you want from the LLM. So how I think of this, for example, if this is a viable solution, is that you don't have to use American LLMs. There are Chinese LLMs, there's European LLMs, or there's a lot of open source models that you can also train on the data that you think are reasonable for your specific problem. So Teija, if you have any take on this, feel free to let me know. As an American and as a European, I think we might have different views on this, but go for it.
Yeah, I think, obviously you can use different models. I think a lot of the stuff that we're building in certain use cases, we want to use multiple. And that's where we're going to do hallucination checks. You can build other checks in to say, hey, are we biasing this a little too much against something else? So there's ways to kind of get around that. But also I think, again, it's depending on like where you're at in your company and what your immediate goal is and like what are you actually trying to achieve, as Martin said. So I think if you are really close to your user and close to your customer, I think it's worth to check like what's the output. Are you able to help calibrate that in some way and build other checks that it's like your version of calibrating that, right? Because you're going to give your context. So I don't think we should be fully relying on the LLMs to give exactly a right answer, because that's definitely not what they're designed to do. But yeah, what are the different ways that you can circumvent bias? Can you use multiple reference points? Can you build in specific checks for things based on your specific use case or your user? So I think those are other options. And then just continuing to monitor it and see if you're feeling like it's resonating with what real people are saying. So it's just like, again, don't stray too far away, especially if you're using it in that context. Again, I keep talking about users because we're talking about product, but especially when you're doing go-to-market function and sales function, yes, you're talking to real people and you want to understand things, but there's a lot more like doing processes in those functions as opposed to synthesizing, understanding, and empathy. It's a little bit of a different flow. So when I keep coming back to that's why.
And we got one more comment from Sivita. In deterministic tasks, LLMs are good. I want to fix F for a Y system. For non-deterministic human experiences like mental health coaching, support assistant for elderly or women's health, these require more experienced humans in the loop.
Yeah, like these systems are likely going to be vertical solutions. So these would be solutions for, like, for example, mental health. This would be used in a clinic, and this would be a healthcare type of solution. So of course, like for these use cases, there is going to have to be a lot of investment that goes into the data that is going to be provided to the LLM, and then the judge, the human in the loop, is also going to have to be experienced for that. But still, like, I believe that we might not be there yet because you still don't see many LLMs being put into production in healthcare institutions, specifically, and definitely not in European countries because the healthcare institutions are public. So I think we might still have some time for that, but I have no doubt that we'll get there at some point. It's just a matter of the fact that it's very complex. There's still a lot of things for us to improve on, but really still depends on what sort of use case you want to use it for and who you actually trust with the LLMs, with the data, and that's it.
We got a message from Nick Coe. He said, good to see you again, Martin. I've personally found using LLM reviewers go into overkill and overdo simple tasks sometimes. Just curious if there's any parameters in your flow that helps it not go into rabbit holes.
Mm-hmm. Well, this is likely going to be determined by the prompt that you are using. So, like for the LLM as a judge or the LLM reviewer, you should be very straight to the point, ask for very specific outputs, and tell the LLM what it should be expecting and what the desired output looks like for it. I know this is easier said than done because every single build and every single output is going to be different, but you can also experiment with different LLMs. But ultimately, when it comes to LLM as a judge of the prompt, is going to be your biggest leverage, just because that's the biggest component of the LLM. If you want to take it maybe a bit further, you can use maybe open source LLMs and also like provide some additional data for it. Yeah, really depends, I would say.
I have a question. So I know the two examples you gave, one was sales, one was go to market. Do you have any examples related to product teams specifically that you've seen like work really, really well, even if it's just like a more simple function or a simple part of a process as it relates to startups or early stage companies? Because I understand things get, a lot harder to do in a white glove way at scale, but they're important to do when you start. And so at what point have you seen people start to use agents for product? How early, how late? Like, give us some examples maybe related to that.
Well, super nice question. I particularly don't work in product, but I know our product managers within Make and what sort of agents they've discussed, at least with me. I can imagine that there are several different use cases that they have, but like one that we have internally and that is very important for us as an automation platform is translating the insights from the customers into actual product features and improvements of specific components of the product. So what we do is, of course, like we need to do a lot of interviews and we need to take a lot of feedback on scale. And then we need to also prioritize what we're going to be building next. So what we have is we have sort of like a multi-agentic system that is fed through a lot of different like internal data that we have. And whenever we have like our UX research team that takes into consideration, for example, comments, interviews, and different data points that go in, it processes them in a way that helps us to understand the likelihood of which next development is going to provide the most value to the customers. So it's also a project that took, I believe this one was several weeks that until it went into production, just because there's so many different streams of feedback that goes into a tool like Make. And then you also need to score like whose opinion matters more, why it's valuable, like is this a reasonable or relevant comment? Do we take it into consideration? And then also having human in the loop, which is our engineering team, that is going to decide, hey, is this actually worth the time that we would have? And are there any infrastructural challenges that might inhibit this? So there's still a lot of checkpoints where the relevant people need to like have their say, but it still works in a way where the agents do a lot of decision making. So this is what I see internally, and I'm sure that there's more examples, but this is the one that kind of stuck with me when I discussed it.
100%. I think that makes a lot of sense. I think there's so many user research tools, but it's really not a one size fits all. So I think that's a use case where an agent works really, really well, because if you're building that scoring system in on what's important to you, and you're able to actually, almost flag important notes or important pieces, then you can start to give a bit of a roadmap as to the types of insights that seem to be important. Mm-hmm. But I actually find even myself, like when I'm having my AI listen to my calls, I often still like flag a note or something in a research call that's really important, because I often find if I don't do that, I'm not getting actually the proper insights that I need from my research. So I think that's like even additional context that requires user input and listening to be able to put that roadmap together. And then after you have like trends and insights where it's like these types of things have been important, it can look for it in other areas.
Yeah. This is how you can use it on like an individual level. Like I try to do absolutely the same. Of course, not every single time I have time to like highlight everything. But yeah, like you can build very reliable and high value systems that are going to be pretty much uncovering the insights that you can use within the product. I know that when we got our engineering team involved, they built a vector database that helps us to understand different patterns as well, so we can be more data driven to prioritize different updates and different product features. And for Nick specifically, thanks for coming, and hope when you try the open source one, it's going to be a good experience. Might be a bit tricky, but yeah, go for it. I think open source is going to get a lot of attention the next few months.
Martin, Teija, thank you so much for your time and your insights. To all of our audience members, thank you so much for joining. We will follow up with a recording of this session. So if you ever want to go back and take a look at some of these insights, feel free. Also, please follow us on all of the socials so you can keep up to date with these kinds of events. We'll be continuing to do them and would love your input and feedback about the kinds of things you'd like to see. So with that, I'll let you go. Again, Teija and Martin, thank you for your time, and I hope you all have a wonderful day.